All right, so let's get started with our honor of orienteering. We are going to cover question number 1, explain what a topographic map is and what you expect to find on it, and 3 uses of it. So first of all, a topographic map, I would like to know how many of you are familiarized with a topographic map. Topographic map or contour line or topo maps, they go by all these nicknames. So pretty much is a map that has many lines, all right? So you can see in these places, you can see the lines, the long contours that show us, it helps us identify landmarks, it helps us identify the rivers in it, lakes, roads, right? Help us see what buildings might be around. If we have rail tracks, power lines, sometimes we have information desks, rangers offices. It helps us to be able to navigate easily when we go on there. On the difference between a regular map, I will say, is that it helps you see elevations. It helps you see trailing routes, right? It shows you the lines where you can find the path for a trail, for a hiking trail. So let's see what you can find. Some of the uses are to find your location. If you're walking in the woods and you're not familiar, you can use a topographical map to help your location. If you open Google Maps in a state park, you're just gonna see that you're surrounded by green. You're not gonna see things there because they're not paved roads. A lot of times vehicles don't go by those places. So you're gonna see that it's just empty. However, a topographical map is going to give information in there, a lot of information that will help you find your location. It's gonna help you navigate where you want to go, right? If you were going to the office and you're lost, or you were going to the place where they have the showers, it will help you find out. We have terrain information because the contour lines will allow us to see elevations, to see which side is going up, which side is going down, right? Where we have a mountain, where we have a valley, where we have a landmark building, hiking routes, we say, campsites, elevations, latitude and longitude. So let me, instead of trying to explain this in my limited vocabulary, I have a short video to show you with regards to what a topographical map. And I know I have many experienced people in here. If you want to contribute something at the end that was not said on the video, you are welcome to open your mic and tell us that. Right, so let me put that short video regarding topographical maps. And then we're gonna see what they are and how to read it. Whether you're a rock
Whether you're a rock climber, hiker, or video game enthusiast, topographic maps are important in a lot of occasions. In this lesson, we're going to break down what topographic maps are and how to calculate for elevation using them. The most important feature of topographic maps is that they are used to show land elevation using what's called contour lines. For example, at the bottom here, we could say that we have some type of volcano found somewhere, let's say Hawaii. So even though the picture on the right looks like a volcano that we are used to seeing, the picture on the left is the same volcano, just showed in a different way using topographic maps. In real life, if I was to look at this volcano, it's a 3D landform, right? I don't see like every side of it when I'm looking straight on, but I can get the idea that this is probably a very high structure. Topographic maps really break it down and show land elevation without having to do it in a 3D way. Using this 2D format, we can see a lot more of the landscape than if we were just looking at a picture of it. For example, we get a bird's eye view, so we can see things like valleys, bodies of water, sometimes vegetation, all of the things that might be helpful for us in a certain area. Understanding how to read topographic maps is important as well if you would like to use them. The first thing we need to know are what contour lines are. So contour lines we're going to see as big circles going around the page or around the drawing that indicate elevation. We may also see other things like shaded bodies of water. We can also see our highest elevation, which is marked sometimes with an X, but can be marked with other things too. For rivers, they get their own little feature where they draw a little V that shows upstream. And since we know gravity is going to pull water down, obviously they would flow downwards from the mountain or from our highest elevation point, but it's also good to know where they would be. So along with contour lines, we have something called index contour lines. It's still the same idea, but the index contour lines give us a little more information. For example, contour lines really only show us the same elevation. Index contour lines gives us a specific height elevation. This means that we can actually calculate the different heights per contour line. On this map, let's say that I take one line and label it 100 meters and another line and label it 500 meters. These lines that are labeled with the 100 and 500 respectively are called index contour lines. Another important feature of topographic maps is how we can tell how steep something is, the slope of the mountain or landform that we're looking at. So lines that are closer together are actually going to indicate that that is very, very steep. If they're almost touching, we would probably need some type of special rock climbing gear to climb it. But if the lines are more spread out, that usually means we have a gentler slope, so we could probably walk up that area. So lastly, let's look at an example where we are actually calculating for elevation. I'm going to mark on the map 3 different index contour lines. In order to calculate for elevation, you have to subtract at least 2 index contour lines and then divide by the number of contour lines between them. For example, point A has 100 meters or is at a height of 100 meters. Point B is at a height of 300 meters. So if I took those 2 points and then counted how many lines it took to get from point A to point B, which would be 2, I would have 200 meters divided by 2 gives me 100 meters per contour line. So each contour line increases upwards at 100 meters. If you found this helpful, subscribe to my channel.
All right. So to give you a little familiar taste, we all know Cambridgeshire. We're all familiar with how Cambridgeshire's terrain looks like, right? We have the flat part where we have all the buildings. Then we have a lake. But to go to the lake, we know you start going down. In some places, it's very steep, right? We have stairs going down to the lake. So let's see how this will look like in a topographical map. Let me open it 1 second. There's some places you can buy these maps. There are applications that gets you these maps. We have the US, what is it called? The USGC, the US Geological Center that monitors a lot of these maps. So a lot of apps take that information and nowadays they make it available. Back on the day, you had to buy those maps. For sure, now we can find a lot of those for free. So this is Cambridgeshire, right? This is an application, a website that I found online. And I just put the address right here, 680 Bakeridge Road. And we see this is Berkshire. You have here Berkshire Road. You have here that little path that goes up to Montana and Minnesota. We have the lake here, right? This is most likely let me see, coming here, right? We can have the pool over here. We have the auditorium. The little buildings don't appear here, only the main ones, right? These are the ones where we put the sheds and we store the boats on the back. So in here, you're not seeing the youth building. Here, you're not seeing those things are not here. But you can see the space between the lines, correct? You have a lot of space between the lines in here. You know, there's a change in elevation, but it's not that noticeable. You can walk it easily. However, as you go to the lake, you can see how those lines are very close to each other, and then you go to the lake. So you can assume that in this part, it's going to be very steep. As the video was showing, if you want to go over here, you will need to have some type of equipment to secure that you don't slip over and fall down. We have some place over here, we have steps going to the lake to make it secure for to descend. Or another way for you to do it is to walk along transversal, but you still feel the steep, the slope. All right. If you see in this map, we clearly see the bodies of water, right? She was talking about the lakes, the rivers, the streams. They're very clearly identified. And also we can see the index numbers in the contour line. To see, we start very close to the lake. We have 400 feet. Then the next one will be 450. And you see that each one in there is going up 10 feet. 400, 410, 420, 430, 440, 450. Every map will have its different scale. We're going to talk about all this vocabulary in a little bit more. We're going to be defining every one of them, but every map will have a specific scale. Not everything is going to be showing you contour lines every 10 feet of elevation. Sometimes it goes every 80 feet. Sometimes it goes every 100 feet, right? If you're going into the metric system, then it's going to be in meters. But we are in America, so let's stick to feet and let's calculate. All right. So another map that I wanted to show you is this one. This is the park where we're going to be going. This is Harriman State Park. It's a very large park. Second, let me see if it zooms out. There you go. Okay. So you see it's a big map. From far away, you don't see it. Oh, I zoom out too much. Sorry. From far away, you only see green. You only see the limits of the park. But as you come closer, you can see that they're actually giving you the contour lines, right? You can see here the contour lines. You see them? You can see, for instance, in this part where it says the Lake Nawanta. Up in here, we have a circle. You can assume that circle is going to be the high part. And then it's going down towards the lake on both sides. Let's come around Lake Tiorati, which is where we're going to be going. We have the lake, right? And right here, right next to the parking sign, I don't know if you see my pointer, right? Right here on the parking side, you see that I have many little contour lines. And then I have a circle on top. That is indicating that that circle is the high part. And then it's coming down to the lake, right? I might have a difficulty walking up there, but if I see opposite to the other side, the contour lines are more spread out. This is going to be more of an even surface, even altitude where I can walk easily, as opposed to these places where you can see the circles, which means there is a high point in there. So you can recognize by then where you have the high points, where you have the valleys. Again, there's many symbols in this map. We're going to be covering many of them, but I want to show you that every map will have its own legend, right? It will have, not all the maps have the same information. Some maps are more complete, some are less complete, but you have always a legend here. Here's the legend. You have always the legend in there They use different colors, they use different symbols to help you realize what each line means, what information. You can see in here, we have those lines that looks like H's, the two double lines, right? We go to the map. Those most likely are power lines. All right, because a lot of times power lines can be a way for you to locate yourself, to orient where your location. If you get lost, you can find your way. Also, if you get lost, because we were talking about the uses, right? If you get lost, you try to find yourself here, and then you're trying to find out which one is the closest trail, closest hiking trail, and where you can follow it. Are you following it in the direction that it gets closer to the park ranger's office, closest to a place where a campground where you can find help, or you're getting more and more into the woods? This is why it is important for us to be able to read these maps and to have a clear understanding. All right. So that was question 1. I made a very long explanation because I want you to be familiarized with that. So let's go now with question number 2. In question number 2, you have to identify at least 20 symbols. We are going to do a little bit more than 20. So this is the part where I want you to open your mics, because I know many of you already know many of these symbols. So the first one, what do you think the first one is? Let's see,
Airport.
Airport, correct. Airport. Second one?
That's a sport.
Like a boat.
That's,
I think it's in
a yard there, so it's sea.
Something like
It's
water.
a lounge.
It's a lake.
The water something.
Mhm.
boat.
Okay,
It's a boat
okay.
launch.
It's going there. So I heard boat, I heard lake. So it's a launch
A launch
location,
pad.
launch boat. A
Okay.
launch boat. It's a location where you're gonna be able to have
Okay.
a place where your boat can be dropped into the lake. Okay, it's a launch boat. Next one, middle one.
Tent.
And what could that mean? It's a campground. Perfect. Next one. That one. This
One
one
is a
here.
yachting, boating or something.
That's like a boat.
Yes. You can boat. You have boating in there. Boating is that means in that area you can do boating. If there is no symbol, or there is this symbol and it has an X on top, it's gonna be saying what? No boating.
No
there.
boating.
All right. The next one.
Glass.
A glass of wine. Yes. A glass
Water.
of water.
Water.
What could that mean? Drinking fountains, right?
Drinking, yeah.
Water fountains. Okay, so we need those. Sometimes we run out. Okay, the next one, first one.
First aid.
First aid. It could indicate there is a first aid station there. There is a medical center there. You can get assistance, medical assistance. Next one.
Fishing.
Fishing areas, right? Next one.
Dining.
Dining, you have small restaurants or places. If you did not pack your picnic basket, you can go there and get your lunch. Next one.
Car.
It's a car. It's a car. Okay.
Park, a park.
Is it a truck?
A park.
No. This one is a little tricky. This one identifies that four-wheel car can have access, because there are some paths where four-wheel cars are not allowed. So this indicates that you can take your vehicle over there. Next one.
Gas station.
Fuel, gasoline.
Gas station. Perfect.
Yeah.
Let's keep going. The blue one.
Hospital.
Hospital. Next one.
Questions.
Information place.
Yeah.
Information desk. Information office. Right. Next one.
Trash.
Trash or garbage.
Okay, so we'll find the trash cans or the garbage station there where you're gonna dump your trash, because when we camp, we don't want to keep that trash with us, right? What happens if we keep the trash? We get a special visitors at night. You don't want that. You either the small ones or the big ones. You don't want raccoons, you don't want bears. The next one,
A hotel or an inn.
lodging. It can be a
Yeah.
car, it can be a hotel, it can be an inn, it can be some type of accommodations that you have.
Mhm.
Next one,
Parking.
The parking.
parking. Okay. The top. We're gonna go first with the top row. This one,
Picnic table.
The bed.
picnic area. Perfect. Next one,
Something hot. It's a hot.
And there's a flag up to visit, something to do with
this one with the little flag, the house with the little flag.
like a ship.
Shed.
No, is it like a
Rangers.
Rangers. Yes,
Yes.
Rangers. Yes.
Rangers office. Perfect. Next
Mhm.
one,
Cycle.
Recycle.
recycling station. Next one, very important.
Washrooms.
Washroom.
Washrooms.
A restroom.
It can include showers. It can be restrooms, use toilet and
Mhm.
lavatory, or it can include showers too. So it's facilities for bathrooms. Next one,
Is that an ambulance?
Campers.
Ambulance or
yes,
It's a camper.
RVs and campers.
RV? Oh.
Area for
Mhm.
RVs and campers. Okay, lower row. What is this?
Hiking.
Hiking.
Hiking. That means that's a trail. That's where
Mhm.
we're gonna have a trail, right? The next one. This is a tricky one. Maybe you guys know it. This one.
Mm.
It
An
looks
incline.
kind of like a house.
Mhm.
Extinguisher.
No, is it to the no?
Shelter.
Like a rat?
Yeah, somebody said there. Say it again.
Shelter.
It's a shelter. When we're hiking, sometimes parks have linen shelters, which are spaces where you have some type of roofing, some type of
Mhm.
walls guarding you. It's not a full cabin. It's a space where you, as a hiker, can just like get close to that and spend the night. Oh, I want next one.
You go back telephone.
Telephone.
Telephone, and the last one.
Grocery store.
Store, yes, a store where you can find things. All right.
Yeah.
Sometimes along these areas, it's not just a grocery. You find everything in there, right?
Everything. Yeah.
A sandwich to gas to wood and charcoal. You get it. All right. So now, in terms of lines, these are just few. The first one is indicating a bridge. That's where a bridge is gonna be located. The second one is showing you a hiking trail. Now, if you have several hiking trails, the map might show you different hiking trails in different colors. So you will have different colors of hiking trails, and in the legend, it's gonna be telling you what hiking trail is that. Now we have marsh area. You don't want to be walking over there. And these all are lines. I want to make sure these are no longer symbols. These are different lines that you're gonna find in your map. This line with a little semicircle, it's indicating the parking area, right? This line with kind of like a river with a black indication in there is rapids. You don't want to cross over there, right? You don't want to be crossing the river over there. Then you have unpaved road. You see the different line between the hiking trail and the unpaved road. And then you have some bubbles, kind of like that. That's a spring. So let's get back to our trail map, right? Let's go back to our trail map. 1 second. Let me go up here to the legend. Let me see. Oh, it went too far away to the legend. So you see here we have several type of lines. We have a line indicating a major road, a smaller road, a local road, a bike path, marked trail, unmarked trail, the woods, the sidewalk, the gas pipeline, right? And then it shows you that we have contour lines, and the distance between each contour line is 50 feet. So let's go back to our parking lot. We're gonna do a little practice where we were over here in the parking lot. I'm gonna go lower to Lake. Oh, you see here, what is this?
Stockbridge.
No, that was
What is the shelter?
Like
The
the
shelter.
shelter. Okay, so let's say we're hiking along the yellow trail. We
There's a
hike along the
shelter.
yellow trail,
Yes,
then
we
we
can go.
deviate a little bit into the blue trail to find our shelter, and we spend the
Shelter.
night there, right? Because we know we might not make it back to on time. The sun is going down. We don't have enough time to be walking. We don't have equipment to be walking at night, so we're gonna spend the night there. All right, so let's go back to our Lake Tiorati, where our camp is gonna be. You see the parking sign, right? We have 1, 2, 3, 4, 5, 6 lines, 6 contour lines. How many feet are we going up in total? What's the difference between the parking lot to here? Remember that each line is
50.
50 feet. So 50,
So that's 300.
100,
Thr-
150,
mhm.
200, 250,
That's 300.
300 feet. All right, so you say that is 300 feet. I'd rather go around. I'd rather take the blue trail. I go over here, then I connect to the blue trail and I go around, right? Because that's gonna be too difficult. Now, something interesting that we see is that line that is white and red. We can find here the scale. We find the scale in here, right? And in some places we have to be always getting the latest one because sometimes there are storms, and those storms bring down trees. There are slides sometimes, right? Mud slides. We have rainwater flooding. So sometimes some trails are closed. The park ranger closes it. And they will tell you, for instance, don't take the yellow trail because that is closed from this point to this point. We have trees that fell down, or we have mud all over. So we have to always have the latest map, and we have to ask the ranger also when we get there if there is any changes. All right, so now we're gonna go to question. We're gonna continue with our questions. Give me a second. Question number 3. In question number 3, we need to learn the nomenclature of a compass. So now you see a compass here that is flat, right? Because we're talking about contours, we're gonna see this one. But this is not the only type of compass that we have. Let me see if I can put my camera. Let me see if you can see me. We have different type of compasses for different uses, right? This one that I have in my hand, this is also a compass. This is something that I can carry in my hand, and it's gonna help me find a way. But when I have a map, if I need to find my way through a map, because we're doing orienteering, and orienteering we focus specifically on learning how to navigate with our maps, this is gonna be a little difficult to sit on my map. Now, this one particularly has that little hole in there, which allows me to sit it on top of the map and be able to still read through it. However, the ones that are just like this one are slightly a little more challenging to sit on top of a map to be able to read it. The model that I'm showing you in the photo is a specific compass that is designed to be used with maps, right? You see that it's flat, it's transparent, it has a little magnifier. You see the circle in here? That little part is a magnifier. So if your map is too tiny in a certain area that you cannot read it, you locate these ones here. So let's learn the parts. We have these ones, are not that big. You can even hang them on your neck. I'm pretty sure you've seen them around, right? We have the base plate, which is the whole plastic. We have the scales. You can see that on this side, on the right side, it has a different scale than on the right side. On the left, in this one particular one, it has 1/4. You see the scale, 1 to 24,000. On the left, you see that the scale is 1 to 62,500, right? Then we have the rulers on both sides that you can take that and actually start measuring things. And we're gonna learn when we go to our practice, we're gonna actually have a map and we're gonna use this to figure out some of orientation, some locations, okay? Direction of travel. You see that above the magnifier glass, you have an arrow. That arrow is showing you that that's the way you're going. So, because sometimes when you flip things around, you can say, okay, was I going this way to the bottom? Was I going to the top? So it has a clear arrow for you to not be confused. Again, we talk about the magnifier. We have the index pointer. You see it right there, read bearing here. It says read bearing here. So that's where you read it. On the top, it's even marked with red, 2 lines in red. Then we have the dial. We have the declination marks. You see them in vertical, right? Vertical lines, red, going from black to red. We have the orienteering arrow that is going to be pointing towards the north. Then we have the needle that is the one that spins around like a circle, like a clock. That's the needle. And you see that the needle is even, it points which one is the top, which one is the bottom, so you don't get confused when it turns around. And then we have the housing, which is the thing that is holding everything, right? So these are the parts. In your worksheet, what you can do is you can list them or you can draw it if you want. That's up to you. You can even put a photo if you want and label those. Okay, so that is a compass. This is specifically the compass that is used for maps. Now you can have compasses that are more elaborated nowadays. They put a bunch of extra tools in the compass, so it will have more things. But this is the basic one, the very basic one. So we go with next one. Our vocabulary, because we're going to be learning a bunch of things here. And the first one is going to be the elevation. Okay, the elevation is the height of a point relative to sea level. So again, when we were going back to our map, we will see that every line goes up 50 feet, right? So when we have the elevation, we're measuring those 50 feet from the parking lot. But we don't know if the parking lot, how high it is, right? Because for us, we're using the parking lot as a reference. But the overall reference, when we measure altitudes, we measure based on the sea level. So when you hear that says, oh, this mountain is 800 feet above sea level, now you know the altitude. And sometimes that is going to affect how high it is going to affect how much oxygen you can take. Have you heard that climbers, a lot of in many countries, they have altitude sickness, right? That's something to take into consideration because it's the place, that geographical location is so high above the heights, the sea level. And this is going to give us a reference. So it's not only in terms of whether you're flat and then you're going in a steep slope going up, but it's also the altitude, the elevation. The elevation will be in regards to the sea level, right? Then we have the contour interval. The contour interval is going to be the elevation change between the contour lines. As we said, right, between one and another, there's 50 feet. That is a contour interval. If you travel from one contour line to another, your changing elevation will equal to the contour interval. So sometimes we say it's going to be 50 feet, 80 feet, 100 feet, right? In the example, it was giving us every 200 feet. So each map will have its interval. You have to check, it tells you between line and line, or at the bottom, it says every line goes up to certain feet. Then we have the magnetic north. And I want to make sure that you understand there is a magnetic north and there is a true north. We're going to read it, but then we're going to have a short video to explain it and make it more clear for us. The magnetic north is the direction compass will point, which is towards the north magnetic pole. When we say north, we're going north. It's all pointing towards the north pole. So our compass works based on metals. It will point to the magnetic north because our compass works towards the magnet, right? Towards the minerals are in the north in the core. So our compass points to magnetic north. our compass does not point to true north. The North Magnetic Pole is not the same place as the geographic North Pole. The North Magnetic Pole is the point on the Earth's surfaces where the Earth's magnetic field points directly downwards. So because we have all these magnetic fields, the needle of our compass is attracted to that. But the geographical North Pole is slightly different, right? This pole is constantly wandering. The magnetic pole is constantly wandering and is estimated back from 2005 that its position was at 82.7 degrees north and 114.4 degrees west. All right. So it's a specific, it's due to the minerals and all those things that we have in the core of the Earth that make this needle point to that. So let's find out what the true north is. Let me jump here a little bit so we can pair them up, okay? A true north is the direction from any point on the Earth's surface to the geographic North Pole. So let's see what is the difference. I'm going to show you a little video that is going to even help us clarify that slightly more. Let's see, is it here? Yes.
As you know, the sun always sets in the west, so this gives a way of finding the other cardinal directions too, north.
Ruth, it's not showing.
Oh, sorry.
But if you have a compass, you might know.
Sorry, I thought it was showing.
As you know, the sun always sets in the west, so this gives a way of finding the other cardinal directions too, north, south, and east. But if you have a compass, you might notice that the north you find according to the sun and the north to which the compass points aren't exactly the same. The north you find with respect to the sun is called geographic north or true north, whereas the north shown by the compass is known as magnetic north. And these two norths are different. Geographic north lies in the direction of the North Pole, the point where Earth's axis of rotation cuts through the surface. This point marks the center of the Northern Hemisphere and is located in the frozen middle of the Arctic Ocean. Magnetic north, on the other hand, is the direction of the point on Earth's surface where Earth's magnetic field points vertically downward. Because Earth is like a giant magnet, compasses point toward the magnetic poles. These poles are not in fixed positions. Today, magnetic north is located near the geographic North Pole. In 1900, though, it was located on Canadian soil, and today it's moving towards Siberia in Russia.
All right. I hope that cleared up now then that we have a magnetic north and we have a true north. So we're going to continue with our vocabulary then. We're going to go to number 4, declination. I'm sharing my screen. 1 second, declination. Okay, so the declination is the angular difference between the magnetic north and the true north. As we said, they don't align. So that little difference we'll call it declination. Okay. At any particular location on the Earth's surface is called the magnetic declination. In other words, it is how far off a compass is from true north, or the correction that must be applied to a compass reading. That is when you take your compass, right? And you say, okay, the north is that way, right in front of me because my compass is pointing it that way. We know it's like, well, the true compass is slightly off, a little like few angles off. We need to take into consideration that when we're pointing our directions, that declination, how far away our magnetic north that our compass is pointing is to the actual place that we want to go. All right, let's keep going. Now we have a scale. We said that the scale is very important because it gives us a sense in the map of the information that we want to find. It can be indicated by a bar, or it can be indicated in a ratio. Usually you find it, let's say, 1 to 1,000, 1 to 2,500, or you can find the bar. And as you see, I'm gonna go back to the map that we were using. You'll see that they have an actual bar at the bottom. You can find either way, the scale in numbers in a ratio, or you can find the scale bar. This scale is going to enable us to use the map to measure the distance and to determine the distance on the ground. Okay, nowadays, maps usually produced under the metric system because the world works with the metric system, right? However, here in the United States, we use the imperial system, which uses feet. So we work with feet for this class. Maps are usually produced at a standard scale factors, 1 to 10,000, 1 to 5,000, 1 to 100,000. Again, this is with a metric system. And all you need to do is to take a measurement on the map in millimeters. So when you work with a metric system, everything goes from tens to hundreds to thousands. It's easier. With the imperial system, it's slightly different, right? And we try to work in factors of 50s or thousands. So when you have the metric system, you can just convert it to millimeters and multiply it. However, maps from some other countries, like the United States, use imperial system. So we have also other maps that use the imperial system. This map displayed scale ranges, but often they were on the form of 60 chains. A chain is about 22 yards. 1 yard is about 3 feet. Thank you, imperial system. Or 66 feet. Okay, so to 1 inch or 2 miles to 1 inch, etc. So instead of complicating ourselves learning this, let's see it with our own eyes. Let's go back to our map. I believe I had the map here. All right, let's go to the base of our map. And here we find out the scale. So you see 1 bar. So we were wondering, remember, what is that line that is red and white, right and white? It's right here. We have from 0 to 1, we have a segment that is red and a segment that is white. That means that this one is 50 and this one is 50. And then it gives me also from 1 to 2, it gives me a whole red in bar. That is 1 whole mile. So if I wanted to convert this, right, I will measure. I take my compass. It has a ruler on the side, remember? You guys, it had a little numbers like a ruler, and I will measure it and say, okay, so 1 mile is actually equivalent to, let's say, 1/4 of an inch. So I come to my map and I measure how many miles is actually from my parking lot. Let's go back to the Lake T or at T here. Okay, so how far is going to be from the parking lot to this other end of the lake? So I would take my compass here and measure it, right? And I say, okay, it's 3 inches. And I notice that 1 mile is 1/2 inch. So how much is that gonna be? 1, 2, 3, 4, 5, 6. That's gonna be 6 miles. So I know this is 6 miles. This is how we convert it. Now, I don't expect you to get all these just from the Zoom seminar. This is why we're gonna do this theory. This when we go to our wilderness camping. I'm gonna try to cover it during the pre-camp too for some of you that might not be able to go to the wilderness camping, so you can complete this honor. Right, so you can attend on the 9th, on Sunday 10th, and we will cover this. All right. So we know then that we have a scale, and that scale is going to help us realize how many miles away we're from point A to point B. All right. Let's keep going with our vocabulary, with our terms. Then we are at measuring. Measuring is the act of determining the distance on a map and translating it to distances on the ground. Just what we did, the example of how long was from the parking lot to the other end of the park, that is, we were measuring. In order to do this translation, you must know the map's scale, which was the first thing that we did, right? We went to measure, okay, this one, half an inch is equal to a mile, sorry, and this is how we make that conversion. Measuring can be done with a ruler or with calipers, okay? Now we have the back azimuth, and the back azimuth is counterpart that is just called the azimuth. So let's find out first what the azimuth is in order to understand better what is the back azimuth. The azimuth is a compass bearing expressed in degrees. There are 360 degrees in a circle. A circle goes, when you measure all the degrees in a circle, the full round, the full loop is going to be 360. And north is, by convention, 0, right? So east is going to be 90 degrees, south is going to be 180, and west is going to be 270. While azimuth expresses the compass bearing in the direction of interest where you are going. So let's go to our figure, right? We have here in the red line, the first circle, this is 0, but this is also where 360 meets. And you can measure azimuth going to 45 degrees. You're gonna know, okay, that's north. What will be that? Northeast, right? Then we have over here, we have east. Then we have south. Then we have southeast over here. And you can measure in degrees. Now, the back azimuth is going to be the opposite, exactly opposed to that. So when you're measuring, we said it's a compass bearing. Remember that we have the bearing here, and it's giving me my direction. This arrow, as I move it in the map, is going to be pointing towards where I want to go. My azimuth is where I want to go. My back azimuth is where I'm coming from. It's the opposite. So my azimuth, when I place this on my map, my needle is going to move. It's going to give me a degree. That's where I'm going. It's pointing towards my azimuth, and the back, what is left here, that's my back azimuth. So let's read that definition. The back azimuth expresses the compass bearing in exactly the opposite direction you are going. The azimuth is pointing to where you want to go. The back azimuth points to where you're coming from. The back azimuth can be calculated by adding or subtracting 180 degrees from the azimuth, because we work with the degrees of the circle. And we're going to be doing this exercise of finding out what your azimuth is and what your back azimuth is when we do our practice on the field at our pre-camp or our wilderness camp. Then we come back to the true north. We kind of covered it already. The true north is going to be the geographical location that we know as north. And finally, the distance is the measure of length, or how far apart 2 points are away from each other. I understand these terms might be a little complicated, but we're going to be practicing and using them, and they're going to be feeling less threatening when we go to our wilderness camp. So please be patient with that. Number 5, what kind of, and this is the last question we're going to do, what kind of a sleeping bag? Oh, sorry, no, this is from another. We covered until up to number 4. Let me go to the worksheet. Right? 5 and 6, they say demonstrate. So these are things that we need to do on the field. Number 7, we will be learning 2 methods to correct for declination. That means when we read our compass, we know how to reorient ourselves to not follow the magnetic north, but the true north. We're going to learn these 2 on the spot, right? We're gonna learn when it's needed, because not always is needed, right? There's some cases when you don't need to do that calculation to find your true north. Number 8, to orient yourself, it's something that we're gonna do in the field, and that resection, we will also do it on the field. So up to now, we've done all the theory that is up to question number 4, and 5 through 9, we will do it, 5 to 10, we will do it in our pre-camp session, August 10, and our wilderness camping, August 15 to the 17th. All right, thank you so much for your patience. I want to know if you have questions. I know you're gonna have a lot of questions, but most likely those are because we're only doing theory right now, but I want to hear from you.
Ruth, I have a question. For the second year student, we did not do this honor. So how are we going to fulfill the from 5 to 10?
Come to the pre-camp on the 10th. I'll try to put this as one of the first things that we do.
Okay.
And do it just like we did with the PBST. Remember, you guys came, did what you needed to do, and you can go.
What
Okay.
date? Sorry, sorry, Lily.
Yeah, go ahead.
What date is it?
August 10th.
Oh
It's
no,
Sunday.
I won't be there.
I will be giving you by Friday the location. Okay, August 10th. I'm trying to find a park that you can go by train. So because I know many of you don't have transportation, so we're gonna try to find a place in a place that is accessible, right?
Queens, Brooklyn area.
All right. So if you guys have suggestions that we can go, because my obstacle right now is that I know it's summer and a lot of people have barbecues and bring their speakers, and they have sometimes baptism, birthday, gender reveal party, and then we're competing with that. So if you have any suggestions, you can reach out to me, because on Friday I will be giving you the location of that. Okay. Very well, then. If we don't have further questions, we're gonna close our session. Thank you so much for your patience. We went over a few minutes. Sorry for that. Let's bow down our heads and have a word of prayer. Dear Heavenly Father, thank you so much for your blessings, your mercies that you gave us. Thank you for helping us understand through this honor how to read the creation that you did for us, Lord. Help us be able to get the experience that we need to be able to orient ourselves. We don't know when we will need this knowledge, but we want to be prepared. We want to share this knowledge as well with our partners. So help us retain this knowledge, practice, put it in practice as well, and share that to our younger pathfinders. In Jesus' name we pray. Amen. All right. Thank you so much. Let me stop that recording. 1 second.